let's go to the next topic. Sequences. I think that sequence will be the thing that I use the most, I think. So sequences, abbreviation from sequence, provide dynamically expandable storage. So if you're working with C# or you're working with, JavaScript, in JavaScript this would be probably arrays, although I don't expect it to allow different types to be stored. But with C# that would probably be a list or something like that. There are two ways to create sequences, with the add operator and with the new sequence of type T and a number of elements method. Once the sequence is created, it can be modified using the add which item and delete which index. The length of a sequence can be found through length and the maximum index through high. So I guess that would be low and other stuff. I mean, low will be always 0, I presume. The standard items T and pairs, which is tuple of the index and the value, iterators are also available. Perfect. So we can create two variables, A, which will be a sequence 1 to 3, sequence of integers, I presume, with a specific values already, 1, 2, and 3 in it. Then sequence B, which is a new sequence of integers with 3 values, but they are all like default value, right? Nothing added there. Okay, simple enough. So then we can iterate over the A to get an index and a value, and we can modify the B by replacing items 0, 1, and 2 with that value squared. So at this point, B will be 1, 4, and 9. Okay. And then we go over elements 4 to 100. We'll basically add 100 squared ones. So we'll continue. Okay. Because we can extend B to have new elements. And then we delete the 0 element and take end time. We go end time. So that's perfect. So yeah, it basically needs to shift all the elements that exist. So if we delete, that means we don't simply take the first element and 0 it. It means we completely delete it. Okay. And then we can define B as first element of 0 concatenate with B. So it'll be, okay, same as original B. I guess this here, right? Because we replaced it first. Okay, makes sense. But no, it was, yeah, because 1 squared is 1. Okay. So let's take it and let's see at every step if I made a mistake or not. So let's do echo and we say B and we print the B. After first step, we should see the new B and then we have another one. After delete, we should be without an element and the end will be just like before this one. So let's run it. Okay, we started with 0, 0, 0 right here because it was a new sequence, so all the elements were zeroed. Default for integer 0. Then we have 1, 4, and 9 because we assigned indexes from A, which is 0, 1, 2, same as here, squared value of that I. And then we basically went and added 100 more, which is all this. And we printed it. Then we deleted the first one. So instead of starting from 1, we're starting from 4. And then we start from 1 again because we added we concatenated just the first element with the rest. So compiler is smart enough to figure out like, hey, this is integer. Well, this is a sequence of integers. So if I concatenate, I guess I just make sure it's still a whole sequence. Very, very nice. I really like that. So you can add at the beginning of the list. I wonder what the performance is. In JavaScript, it will be not fun to do that. You will need to use that whole whatever I never know what those array operations in JavaScript are. You would need to do something like B is, and you could do A0. Now you would need to specify that that's an array, comma, and then I think something like that. We just extract it. So yeah, I really like that. Compiler figures it out for you. Cool. Immutability. Sequences are dynamically allocated, as in allocated on the heap, not the stack. Okay. But they're immutable unless marked as var. That means that if we'll say let A and give it a value, we can't extend it. Yeah, it will fail because A cannot be assigned to. However, if we'll specify it as a variable, we can do that. Will work without any problem. Sequences passed as argument by value are not modifiable. Sequences passed as argument by value are not modifiable. For example, the following will fail to compile. So we have a procedure that takes a sequence of integers. And if we'll try to save something here, it won't work. Yeah, we need a var here, specified input variable. Okay. Sequence arguments can be mutable if they're passed as argument by reference. So, for example, the parameter is annotated with the var or ref. Yeah, if it's var, this requires this here to be var as well, which is really nice. So I really like that because, you know, compared to Rust, where you need to go the whole gymnastics of borrowing and, you know, passing the ownership, here, it's as simple as, hey, this thing is a variable. I explicitly expect it to change or be changeable. Therefore, you can pass it everywhere. But if you'll just set it to let, it won't let you change it anywhere, wherever you're doing something. So that is interesting. Although, I want to check something. So let's say we'll take this code, okay? We'll take that code, and here this works because we specify this as a variable, right? What if I'm gonna make it let? We'll save it, it'll be unhappy. What if I say var, other, or like this sequence is let's sequence. We'll rename this one, we'll save it. Ah, look at that. Now it'll let us change it if we actually respecified it. So let's say here that echo let sequence is, and we'll print it. And we do the same thing just with this sequence, right? In the beginning, they should be both the same, right? Exactly the same. But if I'll change this sequence, will they both change? Let's try to run it. Ah, look at that. So first thing, they're both all zeros. In the second one, this happened. So what we did here, when we created another variable equals let sequence, we copied it. We copied the whole sequence. We didn't copy the reference to it. Even though it lives on a heap, we don't operate purely on a pointer to it. We actually do the proper thing. That is nice. Okay, and I'm sure at some point we can deal with references and we could actually copy the reference to it as a pointer. I just don't know how to extract a reference to it. If we would say that this is a reference to a sequence of integers, right? We'll save it. Can I do something like this? Nope, because I recall that that's how it worked, but I don't know how to get the reference of it. I have no idea what I'm doing. Hey, let's ask chat, because I don't know if this will be explained anywhere or not. I declared a let variable of type sequence of integer. How can I get a reference to it? And I'll say that I mean reference sequence integer. That should give us some kind of explanation. This is the address operator. Okay, so it's a pointer to a variable. So it's just address. So let's try that. ADDR, right? Type mismatch, got pointer sequence, but expected let sequence. What? New sequence, which is integer of 10. Where's the AI thing? So we have that sequence, numbers, address, numbers. That should work, right? Why doesn't it work? I mean, I understand that we can't print it now. We could just do this, and we could do this, and through that, the reference, and you can just pass it like this, save. Still, let sequence is unhappy. So let's say something didn't work. The error is a mismatch. Let's see if we'll figure it out, because this is really confusing error. And we cannot directly obtain a reference type form from a let variable using the address operator. The address operator returns pointer to the variable, not a reference. In NIM, ref types are typically used for heap allocated objects, while pointer types are used to that. If you want to create a refs, you need to allocate it on a heap using the new keyword. Okay, so I can't just break the whole thing. I need to explicitly specify it from the beginning. And at that point, I have that main reference from which I can get the concrete type. Okay, I guess that makes it impossible to define something as let, with let, and then do shenanigans with it. Right, how did you create the new sequence? New sequence of that. And I couldn't specify this thing. New sequence of integer, right? 10. Save. Nope. Save. This is fine. Can I do 10? As if I was calling a constructor? No, I cannot. So I would need to do for I and 0 to 9. Wait, I could do that. Let sequence add, and we do the 0. And that won't compile because we need this whole thing to be that way. Now it should. So this way I define let's sequence as, oh, what if I'll do that? And now I'll be happy because we have it's let. So I can't do that. This is very interesting. So this will work only if I actually have this whole thing. But yeah, so I already have this as that reference, right? So I just pass on a reference, so they both will be the same. Yeah, this will work. And the sequence, taking a reference, I just wonder if this will actually modify the whole sequence properly or not. What's going to happen? Yeah, that modified the thing because we actually got the actual data and we modified it in place, I presume. And because of that, this is still shared. Okay, so even though this is then redefined here, it still works. Okay, makes sense. What if I'll do this and say that I want the address of it? Okay, so I don't know what address is for anyway, but hey, we learned something. I hope you learned something too, because I don't know how to describe it. It's just I have an idea in my head and I'm just, let's try it, and I'm probing it. Okay, you can copy a sequence passed as argument by value and modify the copy. So procedure do something, we get the sequence, we can copy it, modify it, and get that we change the new one. Okay, so we had the test one here, we did pass it there, even though it's not a variable one, we did that thing, and the first one has been modified. So yeah, that's the thing that we kind of tested.